And today, in the last panel from the Embedded Moldova Conference, we will discuss about different topics related to IoT, smart home, and industrial application. For this, I would like to invite to the stage Mr. Alecu Dragomir, the manager of Orcolia Lux Industrial Automation and Robotics. Now, please give a round of applause. We also invite Andrei Bragarenco, the manager of Micro Lab Center and the lecturer in the Technical University of Moldova. Mr. Bragarenco will join us shortly. Now I would like to invite the manager and founder of ABC Solution, Mr. Iurie Mocanu. We invite Madam Alexandra Maior, CEO Sales, Steinel. And not least, Alexandru Mateescu, Innovative Solutions, also from Steinel. Mr. Bragarenco, please have a seat. Thank you for managing to be here. This panel will be a bit more different. We have a diverse discussion. We will start with Mr. Alecu Dragomir, who will tell us about the activity of their company in terms of industrial robotization. And we invite you, Mr. Dragomir, to tell us shortly what your company is doing so that we understand what industrial robots are.
Hello, everyone. Thank you very much for inviting me to be part of this panel again. In our activity, better to start with introduction. We are all graduates from Technical University, graduated Department of Industrial Automatization. We have such specific department, and it's electromechanics. Now it's called mechatronics. From the times of university, and I've done my master's degree also. I got involved in the automotive sector, but in the former Soviet space did not allow industrial automation on a larger scale. So we focused on industrial automation at the international level. So we started with Italy, Germany, China, United States of America, and broad experience. I started in Italy, then I came to Moldova, or we came to Moldova to bring to our co-nationals the expertise, the knowledge that we've acquired. Now let me turn to robots, which are, from my point of view, the highest and the most complicated level of industrial automation. And we talk here about 4.0 industry, 4.0 industry, which imposes not only the functionality of the system, packing and unpacking, but also it includes some remote controls and other elements. Basically, we from Moldova we control the robots from USA, California, for example. The 4.0 industry. In the Republic of Moldova, we design the mechanical side with engineers, mechanical engineers. We assemble all the solar panels, and also with our engineers we create PLCs, program logic controllers, and we end with the language of the robot. Finally, we go to a customer facility, we work with a team, and during 1 or 2 weeks the project lasts. We do the activity and then we come back successful.
începe de la programarea
The industrial
controlelor
certification implementation starts from PLCs, program logic
și vine să cu
controller
robot. Deci,
implementation,
în
and
robot,
ending with the
aș vrea să
robots.
mă expun,
For the
iarăși
robotics
când verifici
side, I
complexitatea.
want to say that there are
Deci
different
aici
complexity
avem
levels.
un robot unitatea, da?
Well, look at here, we have an image of
un așa robot paletează de cutii de carton.
palletizing, cardboard palletizing
Deci,
robot.
relativ simplu.
This is not
Sunt
a
aplicații
very
mai complexe care se numesc
complicated application. We have more complex applications where, like convert tracking type, we have a series of robots which are synchronized to recognize on a specific production line the orientation of products in order to pack them, biscuits or other topics, other elements to be packed.
Deci n-am adus mult text aici.
I didn't put too much text on the screen, just some examples, some videos, in order for you to be able to understand what we are doing from inside Moldova in terms of export.
Iată aici robotul.
You can see here the robot working with the pizza boxes, cardboard boxes. You know their sizes, their dimensions. In Italy, they are produced on a in a mass production process. They are delivered to pizza shops and then they are used. So this is one
Ce
app.
am zis este relativ simplu.
Well, that's a relatively simple
Altfel de
example.
de exemplu,
Different,
da?
other different types of cardboard boxes. You can see this conveyor and all this system is designed in Moldova based on the experience that was acquired abroad.
Ca să fiu mai succint, nu știu, avem timp.
I don't know if we have more time. I'll try to be brief and to let you see another application. As you can see, we have here the final product which goes for logistical distribution.
Robotul din California.
We have here the robot from California. You know very well that the delivery of equipment and the appliances is done in specific cardboard boxes, polystyrol. But in the United States, we promote the idea of packing the product not in plastic package, but in recycled products from recycled material. Everything to be able to be recycled. So our robot is putting its packing, is gathering all these boxes together. The robot is wrapping them boxes. So we have a fully automatized line in the cardboard industry.
Trecem mai departe. Deci, ce vreau să vă spun eu despre complexitate.
What I wanted to tell you about the complexity of the process. Maybe I will
Deci, o să vedeți
have the pause on the video. You can see here in the video a smart scanner, a Connex product. It's an American product. So this smart camera, is taking photos of the products and they put them, deploy them for every robot. Every robot has an identified product and they take the product and put on the line that they need to. So for example, we can see that the product is coming in chaotic order, and using such an application, all the objects are targeted for the respective robot. We might have biscuits, we might have other types of products for like air fresheners or other elements. It doesn't matter. Basically, the cam is set up and the connect is connected to the robot. These are some conveyor tracking. Every robot is synchronized with two additional conveyors, and they receive the command from the cam, and they work with the respective product they receive the command for. As an idea, such systems are very complex. They are for operation, their process to start could take months or years.
Bine.
I don't know if you have
La un
something
moment,
else
v-am explicat cu, nu
as
știu,
videos,
două,
but I try to explain you by visual elements how this works, but behind the curtains, this is more complex and more complicated. Thank you very much, Mr. Dragomir. Your example to create industrial robots proves once again that the competencies of engineers in Moldova go far much beyond the expectations of the international market. Thank you very much for the effort you put on developing skills that correspond to the needs requirements on the international market. Please, could you send the pointer? Next, we invite Mr. Bragarenco to tell us about the talent development in the industrial ecosystem. Mr. Bragarenco is also university lecturer, mentor, and engineer. He has a broad experience in the development of talents in the ecosystems. Good afternoon, everyone. I'm really glad to be here with you. I am Andrei Bragarenco, as it was mentioned. And if to talk about my experience, I'm working with Microlab, but I actually represent with. I've been working represent several sectors. I've started as a university lecturer at Technical University, but I have a broad experience in automotive sector, and what we are trying to do via the engineering microlab activities and based on the activity in the education sector and also looking at the educational and industrial processes, we are trying to build that bridge between education and industry because education should help the industry to create the talents for the industry uh, in order for the effort of industry to absorb challenge to be as lowest as possible. Because you can see that currently the industrial facilities have an enrollment process of starting from 6 months to more, much more time. Depends how complex the sector is. We've also developed a development microlab environment. We've work on the curriculum. We take this over and transform in activity training, the equivalent with the curricula, but also outside the curriculum, which are meant to help us develop multifacetedly. You can see here example of our activity, how we interact in our activity. We have very rich history starting from 2007 when we participated in the continental electromobility competitions. I know there are some colleagues that have worked for Continental or took some experience from there. At least my experience from industry sector starting in 2007 when I first had my master's degree in electronic converters at Gheorghe Sacheniaș. I've displayed the history till 2019, and for the rest, you'll see what comes in the presentation. The sector of automotive gave us an issue, a problem that the students need to solve, and many of the students that were previously my students, I can see now me involved working in the automotive industry, and I think they really would recognize this track on the screen. We had achievements, we had failures, we had some trainings with some embedded schools, but they developed further broader because this didn't work at the moment. So since 2014 till 2021, we had different camps, IoT specifics, automotive, robotics, and my colleagues said that they need specialists in the sense we've switched to that part. We had different hackathons, for example, who would develop a better BCP board because now it's even harder and harder to find specialists in electronics. We can see currently that our products that our students develop in Moldova have not too much continuity because we do not produce machinery, vehicles, or cars, but we produce agro products, robots, because they suggest or help us in help us in solving issues at the local level. And in agriculture, yes, we need electric vehicles, we need Internet of Things, we need robots. So why don't we leverage the opportunities we have at home, focus on agriculture and work in this sector? For example, on the screen here, we can see the agriculture, uh, some representation from the agriculture. We understand that embedded system need focus on embedding a smart decisions every day. So we have the agriculture, and we need to include here technologies in the daily activities. That's the perspective of an engineer in terms of agricultural activities. Starting from 2011, we changed our formula from vertical to horizontal. Since 2021, we do different trainings even upon request. We have four strategic areas. We have electronic consumer, meaning IoT, Internet of Things, robotics, agro IT, and the autonomous vehicles. Starting from 2021, we established with and technical university space. We have an IT arena where different IT elements become alive using agriculture activities. We have a land where we can land plot, and we can develop, we implement, and put in practice our activities. We can use robots, autonomous vehicles, systems for control of parameters, and even drones. As a roadmap for electric vehicles, we propose to work at the beginning with small robots like a simple robotics club, but in the end, we turned out to have agrobots, golf cart, electric vehicle with which we test the automotive technologies. And for our roadmap, we'd like to have vehicles for public roads developed, but for the moment, we test technologies where it is safer to have them implemented, because on a land agricultural land plot, it's safer than on the road. For industrial roadmap, we had the 3D robot. So we followed the path that we've intended to take 10 years ago. For IoT roadmap, we started with some embedded system programming that we developed within our microlab club. But now we have the industrial robots. We connect, for example, all the indicators from nursery to or greenhouse to device to control them. We've had a lot of partners. For example, in the recent year, 2 years, we've had a lot of partners with about 200,000 euros, and this made it possible for different equipment to be purchased. Because if in IT we have a failure, we do a backspace, but in electronics that's not so much possible. For example, if we install an engine of 200 thousand euro and his lifespan is only 5 minutes, for the next lifespan would need 200,000 euro more. That's why we're grateful for the support, and we are looking continuously for partners in order to reach out to those standards for the engineers. Because in order to have engineers focus and working with the advanced technologies, we need to break to misuse some advanced technologies in order to test the capacity of the industrial technology. Thank you very much, Mr. Bragarenco. I'm really glad that you've mentioned that electronic sector, alongside with being very interesting, it's very expensive for the companies that develop technologies. So now we continue with Mr. Iurie Mocanu from ABC Solution Company, and he will talk about his company's expertise in terms of embedded systems. Hello, my name is Iurie Mocanu, director of ABC Solutions Company. As you can see, the company is ISO certified in ISO 27000 and ISO 9001. I can tell you that the company is looking at different solutions for different problems. So based on that, I will tell you about our company's activity. The company was established in 2006, but basically we've started to work in information technologies since 2017. The main topics were oil companies and telecommunications banks. The first, I think, was to develop and implement the GPS system online. This system was installed at the Ministry of Internal Affairs, and it was for different services within 112 emergency unit. The second was developing and installing smart solutions for LED screens for banks and gas stations. Another solution was for public transportation management and the electronic boards, indicating the waiting time at the bus stations. And next were customized solutions for OTA, DMS, ECM for telecom operator. These are basically the our activities products which are tested and already sold. You can see here the first smart solution and autonomous solution for LED screen management. I will stop basically on how the topological solution looks like. You can see on the screen. But in terms of product or output, we've developed a board. You can see here on the left side, and the case, the frame for this plate for the board. For the screens, you can see the diodes, the lighting elements, and you can see finally how the board looks like that is installed with the bank. If we look on the left side, we could do a mass production based on one developed board. Everything is standardized, everything is functioning. You can see that this solution is implemented with one of the banks, and it is also implemented together with a gas station. That was basically all from my side. Thank you very much. Thank you very much, Mr. Mocanu. We really appreciate the effort of ABC solution in developing these electronic solutions for gas stations and banks. We really hope that these solutions will be implemented also on other levels, not only in banking sector or gas stations. Now I continue with the colleagues from Steinel company. We'll have Madam Alexandra Maior, CEO Sales Officer, CEO Sales, and Mr. Alexandru Mateescu, Specialist in Innovative Solutions, Department Steinel. They will talk about automation of buildings, quite topical subject nowadays, and I'd be very curious to find out about the trends of smart buildings in the next future. Good afternoon, and thank you very much for the invitation. We really hope that we'll be able to share with you all the information that we have about the smart building as of today. Let me start by briefly saying about Steinel a few words. Steinel, or how we like to be called, the inventors company. We produce and distribute lighting bulbs, lighting devices to produce hot air tools and glue, uh, hot glue guns. Glue guns. We try to develop products in order to make people's life better. We will try to talk a little bit about our reference points, our milestones. The most important being in 1987 when we've invited the motion sensor source of light. Next, we've invented the high frequency sensor in first sensor in the world, and most recently a sensor that detects real time presence or absence for elements. And we like to say that we will develop further. Our mother company or parent company is in Germany, and we are really proud to say that all our production is spread all across Europe. One is even in Chisinau and the other in Romania at Curtea de Argeș. And our facilities, our productions are in Brașov and some other locations. We have approach called Solutions for Tomorrow, meaning that we develop solutions as of today in order to have a brighter future. It means that we focus a lot on the comfort of people, but we do not uh, overlook the sustainability aspect. For example, we want to give the people the possibility to have lower electricity bills and to reduce the carbon footprint because we have uh, big requirements on the market and we need to comply with these requirements on the market. We like to say that we give solutions and products. Solutions starting from basic on off, meaning a sensor lamp, meaning that when you get into the premise, it just turns on when we get in and turns off when we get out. In terms of smart solutions, we've got a little beyond the stage of smart home lighting control or other components from the home based on the phone. For us, smart buildings is having buildings that feel and react and respond. Uh, Currently, almost all of us have a car, the smartest object that we might have, and this reacts, informs us if it rains. For example, uh, the devices react to cleaning the windows, different other elements. We need to have the same thing with the buildings to ensure our comfort. And starting from these ideas, we've developed several solutions. One of these being the one called connected lighting. This involves actually a series of products having a Bluetooth mesh protocol built in, and they communicate between each other. We've received the award for this as being the most sustainable lighting system. Basically, we have a lightning light bulb that has integrated the motion sensor system. And for example, when we and Bluetooth mesh, when installed in a parking, they communicate with via this Bluetooth. We do not need the wire connection. Therefore, costs for implementation are not so high, and the setting of parameters is done with the phone. Well, everybody has currently a phone, and it's easier for us to set up the parameters for a product. By this, we want to reduce the consumption of energy by 95% and also focus on reducing the CO2 emissions at maximum. I will leave my colleague now, Alexandru, to tell you something about the most innovative products that we have in our portfolio. Thank you. Thank you very much for the invitation.
Steinel
Steinel has the widest range of sensors, and it is a pioneer in this area. And we have infrared sensors, high frequency US sensors, optical sensors, and the newest technology, the one that can detect human presence, even when we breathe and our chest is moving. Steinel has identified this trend of having sensors in integrated systems, and has created most sensors for this area. This way, we have the possibility to integrate them into existing networks, power, Internet of Things, and other systems. Our most intelligent sensor is now a multi-sensor true presence. It can detect the real presence in a room, temperature, humidity, CO2 level, particles, and so on. And we will launch the smoke sensor also. This sensor is integrated in all BMS systems that we have at the moment. And since we discussed about batteries, for them BMS meant battery management system. For us, it is a building management system. In Frankfurt this year, at the Light and Building Fair, we have launched another infrared sensor, and this, together with artificial intelligence we are using currently, help us identify the human silhouette, and it can identify the persons in a room. It can track where they are moving and create different areas where it identifies movement. Also, this person counting technology, we can see where we can have constant lighting, we can see the CO2 level, the noise level, and so on. Also, this year we have launched a software capstone that somehow closes this cycle, and we could make the connection between sensors and software. And thanks to this software, we can read data transmitted by our sensors in one interface. In Romania, we have started very interesting projects in the area of education. The first intelligent school in Romania has used our sensors, and they control the level of light, offering constant light throughout the day. Based on the presence, they control the level of heat and ventilation in the room. This is what a dashboard of the KNX system, where the sensors were integrated, looks like. It can be controlled remotely, and we can see the CO2 level, the temperature, we can control the level of light, and we can see when someone is present in a room or not. This is a reference building for us. It was built according to the ACEM standards, and it has the lowest consumption of kilowatt per square meter per year that we have seen so far, 26.6. Most of the buildings nowadays consume more than 150 kilowatts, and this is a reference point for sustainability. And with the help of our sensors, this building can turn on the light when a person is in a building only. It can increase or decrease the level of light in the building. It can control the temperature, and it can start the ventilation when the level of CO2 is high. This was all from our part. Thank you very much. Thank you very much for the interactive presentation. I would like to applaud everyone present in this panel. Let's thank them with a round of applause.